Hi, my name is Kira Cole, and this is my teammate, Alicia Mitchell. We're a team of 2 computer engineers working on Pison, or Pison iOS integration. So Pison is a startup company whose mission is to offer easy-to-use, wearable technology that enables control or interaction with computing devices. One example is shown here. As you lift your finger, it's actually able to sense that motion, and that's right here when it has a peak in the graph. And being able to sense what motions you've made is what will ultimately allow you to control these devices remotely. So our project motivation is to get more compatibility. So right now they already have a system, but it only works with Android and with Windows operating systems. So the problem is that it still needs macOS and iOS support. And this means that it will be able to sell to Apple customers as well. So we believe that the economic impact could be huge because Apple's share over both of these markets, the smartphone and computing markets, is huge. And this just means more customers, it means more sales, and ultimately it just means more recognition for Pison within the wearable tech and assistive tech markets. So one of our most recent technical accomplishments is a Java native interface implementation. And the reason that we needed this is because in order to interact with Apple's Bluetooth hardware, you need core Bluetooth functions. And what this means is that you would need to write these in Objective-C and Swift. And that creates some pretty big compatibility issues with Java and Objective-C, which do not understand each other at all. So we needed to create an interface solution, the Java Native Interface, or JNI. So this actually proved to be pretty challenging, and one of the first challenges that we initially ran into was simply compiling and running the program. When you're writing in one language, it's as simple as 2 terminal commands, one to compile and then one to run. But when you're using JNI, you have a lot more to worry about, and some of that is shown here. So you have the C++ file to worry about, you have the Java file, their shared library, and then you also have the JNI header file as well. Another problem we ran into was debugging. So you can no longer just step through line by line and look at what's happening with your variables. There's no way to just easily step through from Java to C++, so you kind of have to just manually figure out where all of your errors are. Another issue is that JNI errors tend to take down the entire Java virtual machine, and that just means everything crashes and it leads to really obscure messages, and they're really hard to debug. So basically, if you speak a different language as someone else, what you need to communicate is a translator, and that's exactly what JNI does. So you can't have from Java a way to directly invoke a C++ function because it will not understand that data type. So what it does is it asks JNI, these functions, to translate everything. So it translates it and asks the same question to C++. It will answer that question, translate it back into something that Java can understand again, which is the binary equivalent. And so we were able to successfully translate information between these 2 languages, namely the 3 data types that we are most concerned about, which are integers, strings, and arrays.
So another key accomplishment is scan.js. Scan.js is a JavaScript code that we wrote in order to learn more about Bluetooth communication. Scan.js was written using a platform called Noble. Noble allows a user to input a JavaScript code and it translates it to Objective-C in order to communicate with Bluetooth hardware. We wrote an example code so we could learn more about this process because that's what we would ultimately be doing for our Bluetooth manager code. So to the left here, you can see that scan.js scans for a device, and once it finds one, it connects to it. After connecting to it, services are made available, and these services hold information about the device, such as manufacturer information and battery information. Along with these services are characteristics. Characteristics contain a value such as battery percentage. With these characteristics, you can also get notifications. These notifications can be, when your battery level drops below 10%, you would be notified in order to charge your device. This is the basis for our Bluetooth manager code. So another key accomplishment is our Bluetooth manager code. As of right now, we have it scanning for Bluetooth devices, and it stores the Bluetooth device's name, and it also prints it to the console so the user can see that a device has been found. Once it has the device's name, it also stores the Universally Unique Identifier, or UUID. This is the same as a MAC address for a Windows computer. Apple does not make MAC addresses available because only some devices support it. So instead, they use universally unique identifiers, which are, as the name implies, universally unique to each device. So as you can see here, these are some UUIDs that are available to these devices. This code currently prints 10 devices, and that's what it finds. You can change the number so that it prints more, finds more, but it currently prints this. So our future accomplishments include having Mac OS integration fully completed, and so that would mean that we have to take our Objective-C code, our Bluetooth Manager code, and translate it so that it communicates with Java, as Kira mentioned, using a JNI. Next, we would have to implement iOS mobile. That would be doing the same thing as Mac OS. It would scan for Bluetooth devices, connect to Bluetooth devices. It would also populate services and get notifications of data changes. We also have to implement a graphical user interface, or a GUI, and we would do it so that it would display a stream of data. So you would see information from the device as motions are monitored in order to see raw data on the screen. But our best anticipated outcomes include having Mac OS integration completed, iOS integration completed, and our graphical user interface. The only difference between our remaining challenges and our best anticipated outcome is, if time permits, we would be able to have a plot of the data so you can see the actual spike of data when when a motion is registered. We would like to thank all of the continued support we've had during this project.